we want to factorise 2x cubed plus 10x squared plus 11x minus 3. And the first step in doing this has to be to find a factor. We can use the factor theorem to do this, because if we have that f of x is equal to 2x cubed plus x squared plus 11x minus 3, and we can find a value of x that makes this equal to 0, then we'll have found a factor. We're just going to use a search pattern to do this. So we could try f of 1, and we evaluate, substituting 1 in for x. If we evaluate this, then 2 plus 10 plus 11 take away 3 is equal to 20, so x minus 1 would not be a factor. We don't really need to know the exact value of each of these evaluations. All we need to decide is whether or not it's equal to 0. If we calculate this one, we find that it's not equal to 0, and then we move on. We need to keep searching until we find one that is equal to 0. 2 times 2 cubed would give us 16. 10 times 2 squared gives 40. Then 22, take away 3, and this is clearly not equal to 0. If we try f of minus 2, we get minus 16 plus 40 minus 22, take away 3, and once again this is not 0. If we try f of 3, we get 2 times 3 cubed, which is 2 times 27, which is 54. Then 90, add 33, take away 3, and this is clearly not 0. If we try f of minus 3, we get minus 54, add 90, take away 33, take away 3, and this is equal to 0. And from what we've discussed before, this means that we've found x plus 3 as a factor. Now that we know x plus 3 is a factor, we need to look for the other factor. One way of doing this is to do a division. Divide x plus 3 into the original polynomial. I'm going to do this quite quickly here, but if you don't follow it, you should go back and review the section on dividing polynomials. X into 2x cubed, 2x squared. Multiplying gives 2x cubed and 6x squared. Subtract and bring down the 11x. X into 4x squared goes 4x. Multiplying gives 4x squared and 12x. Subtract and we get minus x. Bring down the minus 3. This would give us minus 1, and multiplying gives minus x minus 3, a remainder of 0, which of course we'd expect since x plus 3 is a factor. This is the quotient, so we can write that f of x is equal to x plus 3 times 2x squared plus 4x minus 1. This is now factorized into two factors, And if we could factorize the quadratic, then we would do this, but in this case the quadratic does not factorize into two further brackets. An alternative approach when we reach this stage is to look for our factor using an identity. F of x is x plus 3, and we know that what goes into this bracket must be a quadratic since the original expression is a cubic. The highest term has to be an x cubed, so the first term in this bracket has to be an x squared to give us the x cubed. Since it's a quadratic, we could say it's ax squared plus bx plus c, and we want to find the values of a, b and c. This multiplication would be the only one that gave us a cubic term, and it gives us ax cubed. So we can compare directly here and see that a must be equal to 2. The only term that would give us just a number would be this one. There's no x in it, and it's 3c. The constant term here is minus 3, so it follows that c must be equal to minus 1. Now we need to use one other term. I'm going to look at the x squared term. This would give me an x squared term. It would give me 3ax squared. And this would give me an x squared term. It would give me plus b x squared. We know, however, that a is equal to 2, so this is 6x squared plus bx squared, and this has to be the same as 10x squared. It follows that b must be equal to 4, and so we've found a, b and c, and we can write down x plus 3, 2x squared plus 4x minus 1, and if we could factorize the quadratic into two brackets, we would do so, but this one does not factorize.